5.4 is all about solving proportions. Now, we just spent a lot of time on 5.3 going over how to write proportions, and then in 5.4 we're going to go over the 3 different methods of actually solving out the proportions. So the objective or topic is that by the end of this lesson, I will be able to fluently, which means to very accurately and quickly complete the 5.4 Big Ideas assignment. So hopefully after this video you feel that the 5.4 Big Ideas assignment is pretty straightforward. The essential question: how can you use ratios and cross products to solve proportions? All right, so we have our key idea here, and that key idea tells us that there are 3 different methods for solving proportions. And so just as a reminder, a proportion is where one ratio is equal to another ratio. So let's just go ahead and remind ourselves about that by putting that in our questions. Is how do we define as proportion? And we would define a proportion by saying that a ratio or rate equal to another ratio or rate. For example, we could say something like 1/2 is the same as 4/8, or 1:2 is the same as 4:8. Okay, so these 3 methods that we will be going over for how to solve proportions include using mental math. So just looking at the ratios and trying to determine mentally how we would get from one number to the other and what we have to do to the denominator in order to match the numerator. Method 2, use the multiplication property of equality. So if you don't recall, this multiplication property of equality is actually a chapter 4 concept where we are going to multiply both sides by a number in order to solve for x. So it's kind of like an equation where we're solving out for a variable. And then lastly, and my favorite, is use cross product property. So look at the cross products of the proportions and then solve for the unknown, which also involves a little bit of chapter 4 because you'll be having to use equations. So let's try out those 3 methods now with this example. Let's go ahead and put method 1 here. So method 1 is to use mental math. 5 is to 7 as x is to 21. So mentally, I can see that if the denominator here is 7 and it's going to turn into 21, then this means that I'm going to have to multiply 7 by 3 to get to 21. And if I multiply the bottom of the fraction by 3, or the bottom of the ratio by 3, I'm also going to multiply the top of the ratio by 3 in order to have equivalent fractions, or in this case, equivalent ratios. And so then our value of x is going to be that x is equal to 15 over 21. And these 2 ratios would be considered a proportion because they are equal to one another. And we know that because if we reduce them both to their simplest form, they would both reduce to 5/7. Method 2. For method 2, it asks us to use the multiplication property of equality. So 5 is to 7 as x is to 21. And we already know x is equal to 15 because we just solved it out in method 1. But the way that we would use the multiplication property of equality is that we would solve for x by multiplying both sides by the denominator, or the denominator that is attached to the x. So for example, if we thought about this in terms of chapter 4, we thought about this as an equation, we would say that x divided by 21 is equal to 5/7. So if x is being divided by 21, then we would multiply 21 to both sides in order to cancel out the division and the 21, because when you put 21 over 21, that gives you just that imaginary 1 next to x. And then we would multiply the left side by 21 because whatever we do to one side of the equation, we'll do to the other side. And we would get that if we reduce this, we do some cross simplifying, we would get 3 times 5, which is 15. So method 2 is essentially solving it out as an equation. If x is being divided by a number, we're going to multiply by that number in order to solve for x. And then lastly, method 3. Five is to 7 as x to 21. My favorite method, and I think the simplest method, is to cross multiply. So we're going to use the cross product property. We're going to multiply 7 times x, which is 7x. And then we're going to multiply 5 times 21. So notice that this is called a cross product because we're multiplying the numbers across from each other. And to multiply is to find the product. So we call that a cross product. 7x equals 5 times 21, which equals 105. And then you would divide both sides by 7. And we've already solved out that x is equal to 15. But those are the 3 methods that you could do it. And so whichever one works for you and you want to use consistently, go ahead and do that. If one works for you sometimes, the other one seems easier other times, go ahead and do that. But as long as you're getting to the right answer, it's not very relevant to me how you're getting to the right answer, as long as you're able to discuss your reasoning behind it. So we've got some on your own here. And on these on your own problems, we're being asked to solve for the variable. Now, like I said, I prefer to use the cross product method, so that's what I'm going to use. Also, particularly because I can't really use mental math, or I mean, I can if I decide to really focus on that, but I think it's faster to use the cross products because 6 to get to 9 isn't an even number. It's not 6 times 1 or 6 times 2. It would actually be 6 times 1.5. And then you would have to think what number times 1.5 would get me to 6. And so rather than trying to input decimals in there, I think it would be easier to find the cross products and then solve for the unknown variable. So we would do 6 times 6, which is 36, is equal to w times 9, which is 9w, and then solve for w by dividing both sides by 9. And we would get that w is equal to 4. Moving on to the next one, 10 times a is equal to 12 times 15. 10 times a is 10a. 12 times 15. Divide both sides by 10. And you would get that a is equal to, here we can simplify 2 of these numbers. So for example, I'm going to simplify 15 and 10. I'm going to turn that into 3 and 2. And then I could still continue to simplify by doing 12 to 6 and 2 to 1. And I would get that 6 times 3 is equal to 18. So a is equal to 18. Moving on to the next one. 6 times 2 is 12. 4 times y is 4y. So 12 is equal to 4y. Divide both sides by 4. And then I would get that y is equal to 3. And so hopefully you're feeling that pretty comfortable with this. Like I said, I like to use the cross product method. I think it's the simplest way to go. Whatever method you want to use is fine with me. But hopefully those on your own didn't seem too difficult. And when it comes to fractions and decimals, you also won't think it's too difficult because we've had a lot of practice with that. And I can definitely see you guys making a lot of improvements on that. All right, example 2, solve proportions using cross product property. Now, we already are using the cross products, is what we did for the on your own. Now, it told us to use multiplication to solve it, which means that we were going to be solving using the multiplication property, that is method 2. But I decided to use cross products, and that's fine if you decide to use cross products as well. I just want you to be able to find the variable. So, for example 2, we're going to do 7 times 8, which equals 56. Set that equal to x times 10, which is 10x. Divide both sides by 10 to get rid of that 10 next to the x, and you'll get that x is equal to 5.6. Just a reminder that anytime you divide a number by 10, what's happening is you're taking that decimal, and you're going to move it over 1 time to the left. Here we've got, on part B, we've got 3 times y, which is 3y. And then we have 9 times 17, which you may not be able to do off the top of your head, but you are able to know that the next step would be to divide both sides by 3. And then you can treat it kind of as a fraction by simplifying down this 9 and this 3. You can turn that 9 into a 3 and that 3 on the bottom into a 1. And then you are left with 3 times 17, which might be a little easier to solve out. 3 times 17 is the same thing as 3 times 10, which is 30. And then 3 times 7, which is 21. And 30 plus 21 equals 51. Okay, I'll let you try the on your own, and then